Welcome to another teardown video. This time it's a Philips sweep generator. So this thing can do different waves, but you can also sweep them. Oh, this one is, oh man, almost impossible to turn this one. So this is the output wave, and I guess you can do manual or automatic sweeps, or you can of course just turn this off and just make a continuous output, right? External modulation, or this is just start maybe. And look at this, it's geared for super accurate adjustments. So this is the manual sweep. Aha, so this is the way that it's sweeping. Oh, okay, impossible to. Oh. And look, the power switch is now different. It's a rotary type. That's pretty cool. Other than that, it's the classic format with this handle. It looks a lot like all the other Philips units from this age. And again, we got those two external power regulators. And what this kind of shows me when I'm looking here on the back, now power in is not hidden behind the shields of the transistors. So I think this is a later model where they have fixed this, because that was of course a problem in earlier versions where the transistors, the shields covered the power half of this text. Also, the voltage setting here is done a little bit different. So now you need to unscrew those two screws and move this little metal locking mechanism for the switch. This looks a little bit like, oops, we forgot to lock the switch. And then they made it like this, if you ask me. This must be the inlet fuse, not the outlet fuse. So to make this real smart, you should have placed the fuse near the power in, right? And again, the transformer is halfway out the back. All right. So what we could do is test this thing. Input and oops, 30, 40 watts. Wow, and it even says 40 watts here. And yes, 41 watts. So that's not too bad, is it? Yes, look at that. The bulb is working. Yay. All right, let's connect the scope and see if there's a signal. So I took the freedom to play a little bit with this unit before I started the video. There are a few things that's a little bit weirdo. I try to explain. So I'm at the moment at a very low range. So this is what it shows here with the red numbers. That is the range from the stop frequency. So the stop frequency is the frequency that is written on the dial. And this is the 1 kilohertz that we see. It's because it's stopped. I am in single Now look at this, the symbol here. It looks like when it's stopped, it should kind of go backwards or go slower, 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 and then restart, right? But what is it doing? Now it restarts and then it goes faster and faster and faster. See? Isn't that a little bit odd? And this is in this mode. So now it's done again and we got the 1 kHz. Let's try and take the top one. This one you expect to reset and then start lowest and then go up and up and up and up, right? Now look what it's doing. So it's gonna go slower and slower and slower until the sweep is done. And then it's going to reset itself. So they printed those two wrong. Isn't that funny? Also, this symbol is also not right. You would expect the frequency to go up to the maximum, down to the minimum, and back to the center of the sweep. But look what happens. Now I'm in this, and it's still at the 1 kHz. Let's try to start it again. See, it goes slower and slower and slower. And then faster and faster and faster. Until it just stops. So half of this, half of that. This line should have gone all the way up, and this line shouldn't have been there. Then it would have been correct. Other than that, amplitude is working, the different output wave formats also works. And the fun thing is, this output and that output, they're individual. So that's pretty cool. How fast it's sweeping is done by this one. So I'm going as fast as I can, because otherwise it's going to be a very, very boring video. But of course it can be from 10 seconds to 100 seconds to do the sweep. And this is how much you're sweeping. So the more you sweep. So now this is the maximum. That means it's the whole scale that I'm sweeping. That means from 10 Hertz to 100 kilohertz. Right? So if I start this, it goes all the way down to 10 Hertz and all the way up to 100 kilohertz. Oh, it actually stopped. Hello. Did you die? Is it alive? 2 Hertz. Well, that's funny. So that means maybe I cranked the... I think it's because I cranked this one all the way up. I should only leave it until 10. So there's a little bit of... If you give it a little bit too much... Let's see if it will restart. Nope. I overloaded its sweep capability. Let's just do half of it then. Okay. Ooh. That looks bad. So at very low frequencies, we got this really, really odd looking signal. Hey, how about we just go and stop the single? We stop the sweep. So this is stopped. And then let's, yes, that is exactly how it looks. Aha. So there is a an odd crossover. But when I dial down to the low frequencies manually, so this is the lowest. Then it is not looking as bad as it was before in the sweep mode. See? Now I'm in center again. Let's try and crank this up again to half. And then start it again. So there was some odd behaviors. And then, okay, I didn't reach the point of badness. All right, maybe it's not supposed to do all the way, but in the manual it says that you should be able to go all the way to the maximum. So let's try something like this. It should be done now, and we restart the sweep. It's also really fun to run in continuous mode. So it's just doing sweeps and sweeps all the time. And again, oopsie, no problems here. But if I crank it all the way up, it's going to look really, really bad. Let's start it. Now it seems to be working. Maybe there was just some old rust in the potentiometers. This is of course what you could expect. But anyway, the unit seems to be alive and running and everything is fantastic. How about we tear it down? Let's see what is inside. And we are inside. This is the on-off switch and the bulb. This is really, really a nice way to do it. Back in the 70s. And this one, see? They put a resistor to dim the brightness. Also the alignment of the bulb and the okay, it's not really aligned, isn't it? Maybe that is why it's so dim. Well, room for improvement. Maybe we could just move this a little bit backwards. And here's the on-off or the start sweep. Look at those trimmers. Those are just from another planet, aren't they? Look at that size. And the frequency potentiometer down here is really, really big. Fascinating mechanical construction. And look at those boards. I think we should try and... Oh, you look down there. What is that fancy pansy IC? I really gotta pull out those boards. And I think they were locked in place by some foam inside the lid. So we should be able to pull those out. And the power supply is also really, really beautiful. This is just the most beautiful one of the 3 Philips units I've been in lately. And, oh, the power supply is a 2-layer board. Look at that. And how about all these? So that means this is maybe a much more recent design. Also look at all the components and stuff. Yeah, I'm gonna pull out those PCBs so we can have a look. Oy, that was so difficult to get the boards out. Are you crazy? Those edge connectors, they were just super, super tight. Look at this board. It is just amazing. Those are high precision resistors. Some really fancy types. BCY55, that is a transistor pair under a shielded case. Because look at this. Here they are. So you probably buy them as a matched pair, and then you get this sexy casing for them. Isn't that just lovely? What you should see here, all this, that's diodes going to resistors and again to some other resistors. And look how that is connected to those circuits up there. So I bet that will be the sweeper. And look how it's done. See? Diodes all the way down there. So that will be all the ranges going down to all the different resistors, and then all those are connected like I shown before. This is really a weird way to connect it, because all the diodes, they're connected again together like that. I got to see the schematic, because that is a little bit interesting, this board, how it's done. And also, why would they design this and then add another little PCB here on top? Those components, they just couldn't fit in here, so they had to add another board. Look at the other PCB. That is very interesting, especially this part. OM112, serial number 4, part number 429. A laboratory sample. Wow, U1. I totally gotta look that one up. I have never seen an IC that interesting before. Try and see here with my fingers how big it is. It is huge. And there are only, I don't know, 4 or 5 pins. Yeah, 5 pins on that thing. What is inside this? And what is it doing? Wow, that is interesting. I just need to know. And again, let's have a look inside. So there's also a really nice pot. Maybe we can stick in the camera like this, can we? Oh, amazing. I'm a little bit too close. Come on. Why is it taking so long? Ooh. And that will be all the... Oh, did you see this? This down here? This is a shielding around a shielded cable. It looks like they're going absolutely bonkers about this one. But it is really nicely made. All sorts of resistors and cables and all. Also look at this nice shaped wires. And the power supply here is also very beautiful. I bet those 2 pots down here in the bottom, that will be voltage adjustment. Oh, and And that is also in a socket, so you can also pull that one out. See? That'll be the minus and the plus 20 volts for everything else. And again, the power supply is just the more or less the identical circuit as they normally use in all those Philips units. Once this is designed and developed and tested and everybody's happy, they just keep using the same power supply system. But this one is made a little bit more nice. Well, the implementation here is more critical, I guess. So look how well they temperature matched the transistor pairs inside a little case. They're just trying to make everything here perform as good as absolutely possible. Oy. I don't know if this is expensive to do in production. All those little flying components and stuff. And this just couldn't be on a PCB or something. Well. This is just how they do it. But let's go and look this up, shall we? That is interesting. So now we are looking at the manual for the PM5162. And here's the link where you can find a really good schematic and the full manual for this product. And then look at this. This fantastic integrated circuit is just called U1. And this is a code number. And then integrated circuit. And that's it. So it's the secret fantastic thingy. But if you look in the schematics, ooh, yeah, that was all the diodes and resistors and the funny thing that I saw. This is not so interesting. Let's go down to the, I think it was here somewhere. Yes, look at that, U1. And what I think is, if you look at this circuit, here is plus 30 volts and minus 30 volts. So I'm sorry if I said wrong. This Philips unit is running plus minus 30. Alright, anyway, so 30 plus goes via this. Look at those resistors and stuff. So that means this is just a voltage supply for this. And all this is doing is setting up this. I think this is a voltage reference of some sort, right? But why would this be here? What is this doing? That's a little bit weird. I think I want to measure what is going on these 2 points and then put it back together, because this is a little bit interesting. And also the schematic here only shows 3 pins and I count 5 on the PCB. And yeah, so this I need to measure. This is just puzzling me a little bit. So I've been tracing down, this is the ground and this is the voltage from the input. So this is the emitter follower delivering the input voltage, and then the output to that other transistor down here. So now I can measure the voltages and put it all together and see what is there. I'm measuring on the 3 wires here. And this is not exactly what I'm expecting. So I get a triangle on the output of IC1, and I get about 5 volts of DC on the input. So now I'm a little bit confused about what is this magic. See, just 5 volts, a little bit more than 5 volt DC on the input of U1. So what the heck is that doing? And why is it looking so big and sexy? What is the point? What is it good for? Hey, it's annoying. I don't know that. Please tell me in the comments if you can look this up, if you know what this magical IC is doing, okay?